On the northern shore of Lake Superior, in the most remote stretch of Michigan's Upper Peninsula, there are mines 10,000 years old. Not caves, not holes scratched into dirt. Mines, with vertical shafts sinking 60 feet into bedrock, horizontal tunnels branching at depth, and stone steps leading into the dark. From these mines, by conservative estimate, between 2 and 5 billion pounds of pure native copper was extracted over 8 millennia. The metal did not need to be smelted because it lay in the rock in solid masses, some weighing several tons. When the first American geologists descended into these shafts in the 1840s, they expected to find traces of small-scale tribal digging. Instead, they found an industrial operation. Thousands of mine pits stretched across 150 miles of the Keweenaw Peninsula. Stone hammers weighing up to 30 pounds lay abandoned at the working faces, hundreds of thousands of them. Wooden scaffolding survived in the cold ground. Fire-blackened walls showed where rock had been cracked by heating and sudden cooling with water. Everything pointed to the same conclusion. This was not the work of a few dozen people. This was the work of thousands, sustained across millennia. But here is what troubled every geologist, every archaeologist, every historian who studied the site. The copper is gone. Billions of pounds of metal were brought to the surface, and they are not anywhere in North America, not in the Ohio mounds, not in any known site across the continent. Less than a tenth of what was mined has ever been accounted for. Where did billions of pounds of copper go, and who exactly was mining it, given that not a single skeleton, not a single dwelling, not a single burial of the miners has ever been found near the shafts? Official science has no answer, only silence. The Keweenaw Peninsula juts into Lake Superior like a broken finger pointing northeast. 75 miles of basalt ridges and boreal forest, surrounded by the coldest, deepest of the Great Lakes. The copper deposits here are unlike anything else on Earth. In most of the world, copper occurs as ore, mixed into rock in concentrations so low that industrial smelting is required to extract it. On the Keweenaw, copper occurs as native metal. Pure metallic copper, sitting in veins and pockets within the basalt, in pieces ranging from flakes to boulders. One mass discovered by modern miners in the 1860s weighed over 500 tons. The geological explanation is ancient lava flows that created the basalt, followed by mineral-rich water depositing copper in pure metallic form as the rock cooled. The result is the largest concentration of native copper on the planet, accessible from the surface. You did not need metallurgy. You did not need a furnace. You needed to dig, extract, and carry it out. Someone did exactly that. The earliest radiocarbon dates from the mining pits place the beginning of extraction at approximately 5000 BC. Some researchers argue for dates as early as 8000 BC, based on charcoal found in the deepest shafts. The most recent activity dates to approximately 1200 BC, when mining appears to have stopped abruptly. That is a minimum of 4000 years, and possibly 8000 years, of continuous extraction from a single deposit. For context, the entire history of ancient Egypt from the First Dynasty to Cleopatra spans 3000 years. The Keweenaw copper operation may have run nearly 3 times longer, and whoever ran it did not leave behind a single permanent settlement within 50 miles of the mines. The first systematic survey of the ancient mines was conducted in the 1840s and 1850s, when modern copper companies began moving into the Keweenaw to exploit the same deposits. What they found stopped them in their tracks. The ancient workings were everywhere. Mine pits dotted the ridge lines for 150 miles along the peninsula and onto Isle Royal, a remote island 30 miles offshore in the middle of Lake Superior. On Isle Royal alone, archaeologists eventually documented over 1,500 ancient mining pits. On the mainland Keweenaw, estimates range from 5,000 to 10,000 individual excavations. These were not shallow scratchings. Many shafts descended 20 feet or more into solid basalt. The miners used fire setting, building fires against the rock face, then throwing cold water on the heated surface to crack it. The broken rock was removed by hand, and exposed copper was pounded free using stone hammers called mauls. The mauls are the most abundant artifact. They range from 10 to 30 pounds, made from granite or diorite cobbles shaped by pecking grooves around their midsections for hafting onto wooden handles. Hundreds of thousands have been found, many cracked and discarded at the working face after breaking from repeated impact. The volume of broken tools implies staggering labour. A mining engineer surveying the ancient workings in 1873 estimated that the total rock removed exceeded the volume excavated for the Erie Canal, demanding thousands of workers operating continuously across centuries. Modern mining companies frequently found that the richest deposits had already been located and extracted by the ancient miners. Whoever they were, they had systematically identified every significant vein across 150 miles of wilderness and mined it until it was exhausted. And then they stopped. And then they left. And the thing they left behind was not copper. It was a question. Here is the arithmetic that nobody in official archaeology wants to do in public. The ancient mines on the Keweenaw Peninsula and Isle Royal removed an estimated 1.5 to 5 billion pounds of copper over a period of at least 4,000 years. The low estimate of 1.5 billion comes from conservative calculations of pit volume and average copper yield per cubic foot of excavated rock. The high estimate of 5 billion comes from mining engineers who compared the ancient workings to modern extraction rates. Either number is enormous. Now look at what has been found. Copper artifacts from the same period across the entire North American continent account for roughly 200 million pounds at the most generous estimate. Most archaeologists put the number far lower. That leaves a gap of at least 1.3 billion pounds at the low end and possibly 4.8 billion pounds at the high end of copper that was mined, brought to the surface and transported somewhere that has never been identified. The standard explanation is that the estimates are wrong, that the mines produce less than engineers calculated, that artifacts have not been found yet, that erosion, recycling and corrosion account for the missing metal. These are not explanations, they are deferrals. Copper does not corrode to nothing in temperate soil. It oxidizes green and survives for millennia. The metal was mined, it was removed, it went somewhere. Independent researchers have pointed to a possibility mainstream archaeology refuses to consider. The copper left North America. The Keweenaw mining timeline, roughly 5000 BC to 1200 BC, overlaps precisely with the Bronze Age in the Old World. Bronze requires enormous quantities of copper. The great civilizations of the Mediterranean, Mesopotamia and Egypt all depended on it, and the known copper sources in Europe and the Near East have never fully accounted for the volume of bronze produced. There is a copper deficit in the Old World and a copper surplus in the New, occurring at exactly the same time. That is either the largest coincidence in metallurgical history or evidence of transatlantic contact 4,000 years before Columbus. The miners themselves are the deepest mystery. Tens of thousands of mine pits, hundreds of thousands of stone tools, charcoal from thousands of fires, wooden scaffolding preserved in cold soil, but no houses, no villages, no permanent structures of any kind within practical distance of the mining operations, no pottery, no middens, the refuse heaps that every long-term human habitation produces, no burials. Not a single skeleton of a miner has been found at or near the Keweenaw sites. This is archaeologically unprecedented. Every other ancient mining operation, from the flint mines of Neolithic England to the gold mines of Egypt, left behind settlements. Miners lived near mines. They ate, slept, disposed of waste, buried their dead. At the Keweenaw, those signatures do not exist. The miners came, worked, and left. Seasonally, the standard explanation suggests. They arrived in summer, when Lake Superior was navigable and the ground was thawed, mined for several months, loaded the copper onto canoes or rafts, and departed before winter. Every year, for 4,000 years, without ever building a permanent base camp, without ever leaving a body behind. The seasonal migration theory requires us to believe that a workforce large enough to operate thousands of pits across 150 miles coordinated annual voyages across the largest freshwater lake on Earth with enough precision to sustain industrial-scale mining for millennia, without any administrative infrastructure that every other civilization required for comparable projects. No granaries, no warehouses, no roads, just stone hammers and canoes and 4,000 years of flawless execution. That is the official explanation. Isle Royale sits 30 miles offshore in Lake Superior. It is one of the most isolated places in the continental United States, accessible only by boat or float plane, wrapped in fog much of the year, frozen in by ice from November to April. Today it is a national park, visited by fewer than 25,000 people annually. Most come for the wolves and moose. Almost none know that beneath the forest floor lie over 1,500 ancient copper mining pits. The Isle Royale mines mirror the mainland operations in every detail: fire setting, stone walls, vertical shafts, no habitation debris. But the island location adds a dimension that the mainland sites do not: logistics. Every miner who worked on Isle Royale had to cross 30 miles of open water on Lake Superior to reach the site. Lake Superior is not a calm body of water. Even modern vessels treat it with caution. Storms can produce waves exceeding 30 feet. Water temperatures hover near freezing year-round. Crossing it in a canoe or hide boat, with a load of stone tools, food provisions, and the expectation of returning with hundreds of pounds of raw copper, is not a casual undertaking. It is an expedition, and it was repeated thousands of times across thousands of years. The copper extracted from Isle Royale had to be transported back across that water. Native copper is heavy, roughly 560 pounds per cubic foot. A single worthwhile piece could weigh hundreds of pounds. Loading that into a watercraft and paddling 30 miles across Superior represents a logistical capability that does not match loosely organized seasonal work parties. It matches a planned supply chain with reliable vessels, experienced crews, and a destination that justified the risk. Where that destination was, and who was waiting for the copper when it arrived, are questions that have been asked for 180 years and answered by no one. The Keweenaw copper mines were active from approximately 5000 BC to 1200 BC. That window is not arbitrary. It corresponds almost exactly to the Bronze Age in the eastern Mediterranean, Mesopotamia, and the Indus Valley. The Bronze Age began when metalworkers discovered that adding roughly 10% tin to molten copper produced an alloy harder than either metal alone. Bronze transformed warfare, agriculture, construction, and trade across the Old World. It required two things in vast quantities: tin and copper. Tin sources were scarce and well documented: Cornwall, the Erzgebirge Mountains, scattered deposits in Anatolia. Copper sources are harder to account for: Cyprus, the Sinai, Anatolia, the Balkans. These are the suppliers credited by mainstream history. But metallurgical analyses of Bronze Age artifacts have long shown chemical signatures that match no known Old World source. The isotopic ratios do not align. The trace element profiles are wrong. There is copper in Bronze Age artifacts whose geological origin has never been satisfactorily identified. At the same time, on the other side of the Atlantic, someone was running the largest copper mining operation in the ancient world, and the metal was vanishing. The mining stopped at 1200 BC. The Bronze Age collapsed at 1200 BC. The simultaneous ending of both phenomena has been noted by independent researchers for decades. Mainstream archaeology treats it as coincidence. The alternative is that the Keweenaw copper fed the Bronze Age, that there was a transatlantic trade route operating for nearly 4,000 years, and that its collapse triggered the civilizational crisis that ended the Bronze Age across the Mediterranean. That hypothesis remains officially unthinkable. But the copper remains officially unaccounted for, and between the unthinkable and the unaccounted, the truth is waiting. The Smithsonian Institution's Bureau of Ethnology was aware of the Keweenaw mines by the 1870s. Field agents visited the sites and filed reports. Artifacts were collected, crated, and shipped to Washington. The response was a framework that has not changed in 150 years. The mines were the work of indigenous peoples engaged in seasonal extraction for local trade networks. No transatlantic contact, no organized civilization, no missing copper problem, because the estimates were dismissed as exaggerated. In 1929, Michigan commissioned a formal archaeological survey of Isle Royale. The team spent 2 summers documenting pits, collecting mauls, and mapping the ancient workings. Their report described the scale in detail, noted the absence of habitation sites, recorded the depth of the shafts, and concluded, without evidence, that the mining was conducted by small seasonal parties. The conclusion did not follow from the data, it preceded it. The report was written to fit a framework, not to challenge one. Since then, funding for Keweenaw archaeology has been minimal. No comprehensive excavation of the mainland sites has ever been conducted. No systematic study of the ancient logistics, the transport routes, the destination of the copper, has been published by any accredited institution. Isle Royale's mines are mentioned on a few Park Service signs. The mainland pits are largely on private land, unprotected, and slowly being reclaimed by the forest. The largest ancient mining operation in the Western Hemisphere is being allowed to vanish without comprehensive record. And the question that would make such a record urgent, where did billions of pounds of copper go, remains the one question no funded researcher is permitted to pursue. The mines are still there. On the Keweenaw, ancient pits dimple the ridgelines under second-growth forest, edges softened by millennia, but geometry unmistakable. On Isle Royale, shafts descend into basalt beneath moss and spruce needles. Stone mauls lie where they were dropped, cracked and abandoned at the face, tools used by hands that left no other trace on this landscape. You can visit Isle Royale today, and stand above a mining pit that was old when the pyramids were new. You can pick up a stone hammer that weighs 20 pounds and feel the groove where a wooden handle was lashed 10,000 years ago. And you can look across 30 miles of cold open water and ask yourself how anyone moved hundreds of pounds of copper across that distance thousands of times across thousands of years without building a single dock, a single warehouse, a single permanent shelter on either shore. 5 billion pounds of copper gone. 4,000 years of continuous mining, documented in broken hammers and fire-blackened rock. A workforce large enough to honeycomb 150 miles of wilderness with mine shafts, and not one burial, not one home, not one name. The official story calls them seasonal indigenous miners feeding a regional trade network. The copper calls that story a lie, because the copper is not in the region, it is not on the continent, it is nowhere that anyone with institutional funding has been willing to look. The mines of Lake Superior are the oldest and largest unsolved industrial mystery in the Western Hemisphere. The rock holds the evidence, the institutions hold their silence, and somewhere, beneath the surface of a question that nobody in authority will ask out loud, 5 billion pounds of copper is waiting to be accounted for.